In this Q&A, we dive further into the applications of quadratics. Enjoy.
I remember you were showing a strategy where it was 2W plus L, and so
Mhm.
it was multiplying. And so when you substitute, obviously back into because your method made sense, but then they showed this method, so I was not sure how
Yeah.
they got 10 minus x by 2 because they didn't explicitly state that it was half the length of half the width was half the length.
Okay, so what they actually did here. Cool. So what they've said is x is going to be the length of the garden, and what you could then say from there, let's see. So they had 20 meters in total, and so a portion of that is going to go to x. Yeah, so even if we do just sort of label it the same sort of way that I would, which would be, in this case, our x equals L, and W can be whatever W happens to be currently. What you would do is say, okay, 20 meters in total, so 20 is equal to, it'll be an x plus 2W, x plus 2W. And so what they're then saying is to get the width portion on its own. Sorry, I should have said I was doing the handwritten notes. Can you follow along easy enough?
Yes.
Yep. To get the W portion on its own, the width, you now just do a subtraction of x. All right, and so we know that the width is therefore going to be, sorry, this would be 2W because there's two widths. So you'd have two W's and then divide everything by 2 there to get a single W on its own. 20 minus x, all divided by 2. And so all they've done to further rearrange that is just distribute that divide by 2. So they're now saying a width, an individual width, is now going to be 10 minus x on 2. And that's why you're seeing what you're seeing there. It's not super
Uh,
well explained there because when they did it in the screen share on the actual book,
oh
they
yeah.
just sort of went straight for the throat there and didn't necessarily create the perimeter equation. They just rearranged it and created it at the same time
So they took it out. So they took it from the perimeter equation. Okay, that makes
from
a lot
perimeter.
more sense actually.
Yeah. Yeah, wasn't a super big fan as to how the book laid that out, so I did my own version of it. But yeah, okay. So other than that, the rest of that tracks fairly well enough.
Yeah, other than that, everything was tracking pretty well.
hmm Are you talking just this question, or just in general for the chapter? The rest of it was
In
fine.
general, for 3L itself, the rest of it made sense. It was just that one part that didn't make much sense because it was explained not very well.
Yeah, understood. Okay. Did you make it through the rest of 3L then? Because we could
Uh,
just leave off where we left. Were you up to?
I didn't exactly, I wouldn't say revisited because I think we looked at like the sixth question, and so I think we stopped it there.
Yeah.
So I think,
Yeah, we did at least that, and then I think we talked about how you'd go about this one. Because that was the
yeah,
same thing as this, just subbing in the points, solve for ABC. I don't think we did any of the actual like questions end to end. We kind of just talked about how they would work.
no, no.
Um, but okay, fair enough. So possibly, if you're looking to get more questions like that, we could jump to the extended responses here, because that'll be a similar sort of idea. What do you think?
Yeah, sure, that would work.
Sweet. Alrighty. So I'll let you have a read from, or starting from question 1, and then we'll go from there.
So for the first question, do we assume that A is 0 and then C is 50 in the x-axis?
Yeah, taking A as the origin, that means A is going to be the point 0, 0, and then, yeah, as you said, C would be 50. Yeah.
So let's say B is 4.5. So
Yep, part of B is
yeah,
4.5. Remember, these are coordinates, so they've got a Y and an X component to them.
yeah, so 4.5, so 25, 4.5.
Yeah, that's it.
Yeah, I'm just trying to remember. So calculating the curve of the arch,
hmm
I'm just trying to remember the way we do it. So y equals, not mx plus c, right? Ax squared plus bx plus c.
You could do AX squared plus BX plus C. Yeah,
Is
that.
there
mm,
another method?
Good question. Yeah. So when you're told or can easily find the turning point, it's often easier to use the turning point form of the quadratic instead. because that will give you an immediate, like the h and k terms from that, and then all you have to do is sub in another known point afterwards, rather than having to do a three-way simultaneous, which you would have to do if you did ax squared plus bx plus c. Make sense?
Right. Yeah. So to calculate turning point form,
Mm-hmm.
I'm just because I'm not exactly familiar with it, so I'm just trying to remember like what it actually could be.
Yeah, no, that's fine. So I'll write it out. It's a x take h all squared plus k, and the whole idea is that the h and k tell you the x and y of your turning point. So if you have an x of 25 and a y of 4.5, that means you now have a bracket x take 25 all squared plus 4.5. So you're familiar with the idea that a subtraction on this means a shift right and a plus means a shift left?
Yes.
Okay. Yeah. So as long as you're fine with that, then that should explain why those are what they are. Maybe we'll just double check the units there. So meters, meters. Okay, everything is in meters. That's good. Because sometimes they might give it to you in different units, so you might have to like convert. Like if this was kilometers, for example, you'd write 4,500 instead of 4.5.
Yeah.
But yeah, that's almost everything we need. There's still just one additional unknown in there.
A is just in this case A is the factor of it, so positive or negative.
Um, it could be, so you could actually tell immediately whether it's positive or negative by looking at the graph.
Yep.
The more difficult thing to find will be the specific value of it. What kind of positive or negative number is it? Like what actual number? So I guess first things first, is it positive or negative based on the,
It's a negative quadratic.
yeah, negative quadratic. That's good. Now, the challenging or more challenging bit would be how do you actually get its value?
I'm assuming it's similar to how we were calculating circular functions,
Mm,
where it was like a cos where cos was like the height of the peaks and trough.
mhm.
So I'm assuming that the a factor is something like that. So do we? So it's but it's not 4.5. It's 0, I think. Oh no, sorry, 0, 1. So it's not.
Okay, so it's a little bit different to how circular functions work. Um, Technically speaking, the a term at the front does the same overall thing. It stretches things vertically. So if I give like two examples of quadratics just off to the side on the handwritten bit, this one here is, we'll call it x squared. Then this one here would be like maybe 7x squared, right? So bigger number at the front means that it shoots up faster. It stretches along the y a lot faster. So it
Oh
still
yeah.
does the same sort of thing. In circular functions, it means doing the peaks and troughs at different values. So the challenging thing with this kind of question is called a families of function style question, and it exists for all types of functions. This a term here, for like most of these kinds of functions, you're going to find it out by subbing in a known point. So currently we've already used a turning point to grab this information here. The next natural thing would be to choose either A or C to sub into here, and then that will eliminate the X and the Y, and then you'll only have A in that equation, so you could then solve for that. So A is probably the easiest one here. It is just the point 0, 0. You could alternately sub in 50, 0. Either of those would work. In fact, in this case, I'm even looking at it now, it would be the same thing, because 50 minus 25 or 0 minus 25 is still going to be basically just 25 squared. So you can do that by hand, of course. This is extended response, so to actually answer it properly, more efficiently, you'd want to then just get the CAS involved here. So from here, you would do a solve, menu 3, 1. You would say 0 equals A. Okay, I've already assigned A to something else, so we'll call it O instead. O times x take 25 all squared plus 4.5. Probably should have put x equals 0 there. comma, O, and you'll get some nasty-ish looking fraction. So it was negative, like we expected. It's but it's also like a different number other than just like -1, for example. Okay.
Yes. All right.
Easy enough how I've used the CAS to go about that.
Oh yeah, yeah. It's just the solve function.
Yeah, just the solve. Yeah, just to make life easier for us, I'll just quickly clear everything else in the CAS to make sure we don't have any weirdness show up there. Okay, did we answer the full question? So, write the formula. Y is the height. X is the horizontal distance.
So
Yeah,
with
well,
asking for the formula, you write down the a into x minus h squared plus k.
yeah. So, final answer for this one would just be, so you would say y equals -9 on 1250 bracket x take 25 all squared plus 4.5, and that's what you give as your final answer.
All right.
Yeah, because it says let y be the height and let x be the horizontal distance, and we've made sure to write that specifically. Cool.
Okay. Yeah. So for B, creating a table of values.
Yeah,
So when it's asking for the graph of the curve, that just means drawing what they drew out in that image.
basically. Yeah. So that's a very poor question, I would say. Calculate a table of values and accurately plot. Um, that could all just be simplified down to just plot the curve. And as you said, it's literally just repeating what they've drawn there, but on an axis instead. So, I mean, it's a little bit different, I guess, because it is an axis. So we know the location of the turning point being 25 and 4.5. We know it goes through 0, 0. We know it goes through 50, 0. Just trying to think, do we have to restrict domain at all?
It didn't really ask for it, so I doubt.
Yeah, but it is still in the context of a bridge. So,
Do we just
hmm,
assume are restricted
yeah,
to 050?
yeah, I think that's the safest. Restricted to 0.50 because if you're saying like y could ever be negative, that doesn't make sense for the scenario that we have, and so this would be how to sketch it.
In an exam, would you assume zero to or restricted domain to 050, or would you just draw it out the full length, which is safer?
The exam should specify. It would say plot it over a valid domain, and it usually does say plot over a valid domain.
And
Sorry, not usually, always.
a valid domain would be like 0 to 50.
Yeah, 0 to 50 would be the valid domain for this one here. There
Right.
were other, like if you go back to the previous chapter, there were other issues like how big could x be for this fence? Well, we can't have negative area, we can't have negative length, that sort of thing. We can't have negative gap. Depending on whatever the scenario is, you'll have a different valid domain.
Right.
Okay, that's that. So yeah, part B was literally just basically repeat this, but on an axis. Okay, part C. At what horizontal distance from A is the height of the arch above the water level equal to 3?
Uh, to do this, I believe you just say y equals 3 and you just sub that back into the equation we had.
Absolutely. Yeah. So because this is extended response, this is where CAS comes in handy. So I mentioned it before in our class. Do you remember how to define functions?
Uh, yeah, you basically just say the value x equals some amount.
So what I'm talking about specifically is how to like put the function that we created into the CAS so it's easier to recall. So this
Oh, yeah.
statement here. So the idea
Yes.
is menu 1 to get to define, and then all you do is call your function, whatever you want to call it, and then then just write out the rest of it. So your a term is going to be this. It was x minus 25 all squared plus 4.5, and that way I don't have to write that out a whole bunch of times. I just need to say h of x, and well, the CAS has expanded it out naturally, but if I were to say this equals this, it would say true, unless I've somehow done something really, really strange. So it's just the expanded version of it because the CAS does whatever it feels like
So you
sometimes.
paste that in, and if you do paste that in, just say equals 3, then it'll solve for x.
Yeah, so you do need to put that into a solve to make that work. So
Ah,
solve 3 equals your function. And you'd say, what are you solving for? So
x.
comma x. And that will be, well, those are possible answers to the quadratic. Now, if we think about what our actual question was asking, what's the horizontal distance? So,
The positive, not the negative.
yeah, the positive. And it doesn't
Say,
say,
yeah, 25. It didn't say valid domain though.
it did
But
mention
it's
valid
implied.
domain, yes, but yeah,
Yeah, it's implied, I think.
it's implied, correct. And the other thing is, do make sure you give your answer as exactly what's written here. Don't do your control enter because this one doesn't say any number of decimal places. And then one final thing would be to say meters at the end because the horizontal distance is in terms of meters. Cool.
Right.
Sweet. Okay, that's that. And then,
D is just the inverse of C. I think it's just asking for 12 meters of x instead of y is 3.
yes, correct. Yeah, so nice and easy on the CAS. It's literally just you plug in h to 12 and, well, you get that fraction.
Or control enter and you get a decimal.
Correct, yeah. And that's probably a good thing to do in an extended response, get both. That way you can see if your answer looks weird or not. Because if you're looking at your graph and you see you've put in 12 meters, so you know 12 meters is approximately there. So I'd expect something pretty close to 4.5, which we do. So it's like a bit of an error checking you can do.
Right.
Okay, that's that. E.
Uh, so it's assuming it's directly under the midpoint, I guess.
Flying platform. It's greatest height above the deck. Well, hang on. Let me have a read of this properly then. A floating platform 20 meters wide is towed under the bridge. So probably this yellow thing.
Yep.
It's the greatest height of the deck if the platform is put out with at least 30 centimeters. Yeah, so you'd say dead center. You'd want it to be dead center. Yeah.
It would maximize the height. So basically, you do horizontal distance from the center. So 20 meters wide, meaning you do 25 meters and you do 15 meters on each side.
Well, this one does say 30 centimeters for horizontal clearance. So are you
Yeah.
saying,
Like, it's like you do, well, if it's asking for 30 centimeter clearance, then you'd say 14.7 meters subtraction from 25.
25?
Because you would restrict your domain to a lesser amount to the maximum height of that point.
Um, 25. Where did the 25 come from again? Is that your
25 is the
horizontal?
midpoint.
The
It's the
midpoint?
midpoint.
Okay.
Yeah, yeah. It's like the horizontal distance B. So
That'd be the
it's like,
center of it, yeah. Okay.
yeah, yeah, the center. So then you subtract 14.7 because it's 50, because it's 10 meters on each side. Sorry, not 14.7. What is it? 9.7 because it's 20 meters on each side.
20 meters on it. 20 meters total wide.
Yeah,
So,
sorry, 20 meters total. So it becomes 10 meters on each side, and then it's 30 centimeters clearance. So 9.7.
okay.
And then so 25 take away 9.7 becomes what's 16, 15.3.
10.3. Yeah. I
And so then
am,
you just calculate that, I guess. But then the x, maybe.
yeah. Honestly, I am kind of having trouble keeping track, like just verbally, what's going on. Do you want to maybe try to do the question and then let me know what the answer is at the end?
Uh, if you just put h of 15.3, it might give you I think it might give you the right answer.
H of, oops, okay. H of 15.3. 3.822. So that will be the height at that spot. Okay, let me just
Yeah, I
go.
think that's the maximum height of the
Yeah, let me just go
yeah,
over
maximum height
the.
of the block
Mhm.
or the tower.
Yeah, I forgot to bring up the answer sheet, so let me quickly find that and just verify that is in fact it. Because normally I'll draw like a little picture to get it, but it seems like you're very good at doing these mentally. Let me see. What chapter was this? 3. Okay. Chapter 3. Uh, 3 extended response. And we were doing E. So 1E. E. Sorry for the wait. Should have had this open up already. 3.736. Okay, so this is a little bit off. So something in what you've said is a little bit different. We should be 3.736.
Mm, right then. So 3.736. That could be it's horizontal, not vertical. Unless it was an error and they meant vertical clearance.
So we're looking for, okay, 30 centimeters horizontal clearance either side we want it to be. So basically, if we start maybe drawing a picture to get a visual, that way I can at least keep track of what we're doing. We have some bridge, we have some
Oh, I
box.
think I know the mistake I made. I think it's not meant to be 9.7 meters. It would actually be 10.3 because you'd have to factor in the extra 30 centimeters, not a less 30 centimeter.
Okay, so
It would
which would you
be
sub in?
14.7.
14.7. Yeah,
Yeah,
okay. So whatever you done there was perfectly fine then.
it was
Okay,
just wrong point 3.
easy. I'm glad you can get it without a picture. I'm a I'm a bit different there, but good. Yeah, either way you get it is totally fine. I guess maybe having some sort of diagram can help you with those like minor errors where it's like you knew what you were doing largely speaking. It was just like a little quick arithmetic error in there. Um, just ways for um, eliminating unnecessary mistakes.
Right.
Okay, question 2 looks very similar to what you've already done. Let me just see if there's anything special worth looking at there. Cut in 2 centimeters, a square, a rectangle. I mean, it's a little bit different. Why not? Yeah, let's have a look.
So 12 centimeters long into two pieces, so well, not 6 each, but so if x is the side length of the square,
Mm-hmm.
then 4x is one length of wire, I believe.
4x is one length. Yep, yep,
So 12 minus 4x is the total length of the rectangle. So 12 minus 4x is like the perimeter.
yep.
And so I'm just thinking 'cause it would be 6 minus 2x equals just length plus width. And they said length is twice the width, so 2w. So 3w equals not fully sure
Mm-hmm.
how to answer this because they give x and then you really have to have a second
You do.
variable because I'm not sure the length of width and I don't know how to get two equations from this.
Yeah, so on that second variable thing, you do just get to choose whatever you want to call that. But as far as where we are at, so what you've currently got is your perimeter equation. So you know perimeter of rectangle, so we can call it maybe PR, would be 12 minus
minus
4x. So you had that, and then the next thing was, so I guess we could even just write perimeter of square, just to have it. Perimeter of square was just 4x. So the thing that's specific here is the rectangular shape has a length that is twice its width. Okay, let's use the form of square. The length is twice its width. So if we think that the perimeter of the rectangle can be broken down into 2 lengths and 2 widths, then hang on, so is x. Do we know if x is the width or the length specifically? Write down dimensions of the
They
width.
just said x is the side of the square, so it doesn't necessarily be specific. So we take L and W as the length and width of the rectangle.
Yeah, okay. So you've got 2L, 2W is equal to this, so the 12 minus 4x, because those have to be the same thing. Now, the interesting thing here is we know the length is twice the width. So instead of saying L, we can say an additional 2W there. So it's
So
going to be
6W.
yeah, so 6W total, 12 minus 4x. So you know that your width is going to be all this divided by 6, and then the length would therefore be double that.
Oh, you can just say it like that. Okay, I was thinking you had to solve for x, and then that's why I got a bit stuck.
So it says, so the way you know whether or not you're solving for x is this statement in the screen share here, in terms of x. It means when you give your answer, you want to have x still in the answer.
Ah, right.
Okay. Yep, so that's that. Part B, just create your area equation. Nothing too crazy there.
A rule minor the square and rectangle. Oh, so A is the area of both.
Both, yeah.
Both. So you do what? So 12. So what? A equals 12 minus 4x by 6 into double it. So into 12 minus 4x by 3.
Yep.
Actually, probably just halve that and say 6x and say 6 minus 2x by 3.
Yeah. So that wasn't fully simplified, obviously, but yeah, you would simplify that down.
And then it would be just what? Plus x squared.
Yeah, plus x squared, because length by width of the square, they're both the same thing.
And then you'd get some equation. It would be like,
yeah,
you get, some equation, you get a full quadratic, I believe.
yeah, absolutely. So highest power there is x squared, so it should be a quadratic at the end. This being tech active, of course, you can just get the CAS to sort that out for you.
Yeah.
Okay, so I guess have a read of that, and while you do, I will just copy down what that area equation is, because I think it'll be important for this question.
So how many of the SACs or exams are actually tech free? Because I don't want to obviously get too reliant on the calculator and then not have it in like my final exam or something.
Well, SACs are school moderated, so I can't really answer that. I can say within here, within the community and what you've got access to here, I have an equal split of both.
Right. So is the final like 3-4 like split? Is it tech free and non-tech free, or is it just tech, or is it just like allowed to have tech?
So I'll show you what the format looks like exactly with with past exams. Let's have a look. So this is a 2023 one. Just going to open up both first, and then I'll show you what they're all about. Okay, close. Cool. So this is what your exam 2 will look like. So methods has 2 separate exams. One is a tech active. This is the tech active one, exam 2, and the other was a tech free. That's the exam one.
Right.
So, exam one, you've got an hour and 15 minutes reading time. It's 9 total questions, and the kinds of questions you get given are very stock standard. Like, this page will pretty much always look the same. The numbers will change around, but it'll still be do this exact kind of question. Question two, a slight bit of a wild card. It might be another kind of question like this, or it might be exponentials related, like you can see here. There's like a 50-50 shot of you getting a sketching thing. Um, this one's another kind of sketching thing. More calculus, probability, and so on and so forth. Basically, you'll find the structure of these are quite similar. So you get 15 minutes reading time and an hour to complete that one. Both of them give you approximately 1.5 minutes to solve each mark. So, like this being a 2-mark question, you've got a time budget of about 3 minutes to solve it.
Right. And then in the tech active.
Yep. So I guess one thing I should probably specify with the tech free, it's no calculator. Where does it say? Yeah. So no calculator, no notes, nothing like that. Just pens,
The
pencils.
formula and the formula sheet, I think they say.
Yeah. So formula sheet is on the back of your exam, and it looks exactly like this. So you can see what stuff you do need to know and what stuff you don't. Like a lot of the probability stuff you don't need to memorize, volume areas, some of that, and when you start getting into the calculus stuff, you'll have those there as well. As for exam two, you've got almost double the time, so you've got 2 hours 15 instead, and there's a multi-choice component as well as an extended response component. Multis look exactly like you've always seen. It's just multiple choice. It's A through E. And then the extended responses, they're pretty similar to what we're doing here. So it's like you got a question, multiple parts, follow-up questions, that sort of thing. These ones have a bit more variance in them. It's a bit harder to say what's going on here, but you can at least guarantee what kinds of topics likely to come up. Like there's always going to be some probability, some functions, some calculus, and usually near like the latter, like the very end of it, that's when they start like just sort of throwing stuff at you and making it really hard. The good news about that though is that they'll make it hard and they'll make it worth 1 mark. The idea there being they don't want you to completely bomb the exam because they gave you a 5 mark really hard question. They put these in there to separate students. They want to know if you got that question right, then you're the one that's going to get a really high study score because presumably you get everything else right up until that point.
All right. Because so the hard stuff is generally worth quite little because it's not because they're trying to make sure you don't fail the exam.
I would say the hardest stuff is
Worth
generally
little.
about 1 mark. Yeah, and it's hardest because it's like unique questions. It's not like it's a really really arithmetically demanding thing. It's like, well, this one here. I've done a lot about this question. There's a lot of intuition involved and a lot of playing around with how the calculator works so you can play with the graph. I won't get into details as to what this question is. It's quite complicated. But it's more intuition based rather than you have to do like 700 different computations to get it right. That's what I mean by like the hardest questions. They call them separators.
Yeah. Yeah. I know what you mean.
Yep. Yeah. So that's the structure of the exam, and that's what it's always been.
Yeah, that makes sense. Actually, thank you very much.
Yeah. No worries. But okay. So that was part C. I'll just finish up writing the formula that we might need for it while you have a read of that. Any thoughts so far?
Uh, I'm just thinking determining the length.
Mm-hmm.
If area is lowest. I'm not fully sure how to calculate, so I'm just trying to solve that out on a calculator right now. I'm just putting that.
Oh yeah.
I'm just solving the full equation right now, and I'm now seeing what I can do from there.
How do you mean solving it?
Like, so I've got like 9x. I took because it's over three. It's over three squared, so nine. So I just multiplied it all by nine, and so I'm getting 9x squared plus 6 minus 2x into 12 minus 4x. So I'm just getting the actual equation and seeing if I can do something with that to determine the minimum
Yeah.
area.
Okay. Is that is that the equation that you have for the total area, or just one of the areas?
For the total area.
Yeah, because the total area should be what I have on my CAS here. Sounds like it's a little bit off, unless you've rearranged it some fancy way.
No, I just probably haven't fully simplified it.
Okay.
But
Yeah.
yeah, I think the only difference is that I multiplied the whole thing by nine, and then you probably didn't.
Multiply the whole
Um,
thing by 9. As in, so
like just
you,
got rid of the fractions. I just kept it all in whole numbers.
well, the thing about doing that is you can only really do that if your function equals 0. Otherwise, you're saying 9 times the function is equal to this, which is a little bit different. Um, it works fine if you're solving for x. Like, that's totally fine because you're setting y equals 0. But if you're looking to like observe what the full graph looks like, probably a good idea to leave it exactly as is and sketch that instead.
Ah, right. Okay. Yeah, that actually makes sense. I was looking at a question earlier today. No, it was a lot easier than this, but it was
Mhm.
like it was basically saying that you can't it, I took the fraction as like I took the fraction and I just multiplied it by five to get rid of the thing. But
Mm.
apparently you're not supposed to do that because it changes the value of the equation completely, apparently. So
Yeah, well, I
it was
mean,
pointing exponents, so that was probably why.
yeah, like I'll show you the difference. So this is what h of x looks like, and then when you multiply both sides of that equation by 9, what you're essentially doing is sketching 9 times h of x. And then, well, that's going to be significantly wider if did it break altogether? Maybe. Let's see if zoom fit does anything. Yeah, so just, I know it's a bit of a weird scale there, but the lines are clearly not the same thing.
Oh yeah, I see.
Yeah, so that's what happens when you multiply both, because that technique, I'll just reiterate, only works when you have like a 0 on the other side of that equation. If you're having a full function, then these are two very different things.
And obviously I think we're assuming the area probably isn't zero.
Uh, I mean, it could be.
It could be,
Depends.
but I think it's assumed that it probably isn't, even though it could be. Probably isn't though.
Well, it only takes one of the dimensions to go to 0 for the whole thing to disappear, because they have the same. No, they don't have the same width. Only the square has a width of x, and the rectangle has a different width altogether. Okay, so it's unlikely they'll both go to 0. Yeah.
Yeah, so yeah, so I've just got the equation for area, the 72 plus 14 plus 17x squared minus 48x all over 9.
Okay.
So I'm just not fully sure how to assume the minimum area in this because I can't just keep so I we could substitute areas x as 0, but then that would just mean the side of the square is 0, which means somehow
Mhm. So I guess the first question I'll ask is, what is this equation describing?
describing the area of both the rectangle and the square.
Hmm. Yeah. So on the left-hand side, like the h of x value on my CAS, that a is your area. That is the possible area. Okay. Next question is, what kind of graph do we have?
Uh, Parabola.
Parabola. Yep. Is it positive or negative?
It's a negative graph. Oh, sorry, no, it's positive graph.
Yep, positive parabola. So what do you know? What do we know about the shape of a positive parabola?
It's it's not, I wouldn't say below it, 'cause it's obviously above it, but the parabola is going upwards.
Yeah, going upwards. And so what's implied there is that it has a turning point as its absolute minimum value, doesn't it?
Yes.
Okay.
That
So
minimum point is probably above zero.
probably, yeah. You don't have to assume though. It is saying, well, the first step of this would be to figure out for what value of x do you get a minimum area, right? Because if you know x, then you can sub that into your width equation, and you can then sub that into your length equation to get those dimensions, because those are both written in terms of x. So this being a
And
tech active.
probably just in the tech active exam, you probably just substitute you could probably just plug in the equation and just get a graph and then look at the minimum.
Yes, let me see. So when it comes to like extent of response style things, the answer is usually like some sort of decimal or some root. So I'd shy away from using the graphing tool for like a final answer, but it's good to at least know I can plot my function, I can see the minimum, I can, so this is going menu 6 and then 2 for minimum. Just drag it either side and you'll get some decimal, right? You can't really use that as your value, unfortunately. And so better is to go back to the calculator tool and use this thing called function minimum. So that's under the calculus menu, and it's all the way down here at 7, function minimum. And when you plug in name of your function and then comma x, you're going to get the x value for which you have a minimum. Is that clear?
Oh, you can just have a minimum function.
Yeah. So that tells you the x value for which there is a minimum. If you just like control enter, you see it's 1.41. If you go back to the CAS, 1.41. And so you can be confident that this is the value you want, not the decimal, because we're not told a number of decimal places. Cool.
Right.
So what we've found is x value, right? So we have our function h of x, which describes the total area, and we've just figured out what x value would cause it to be a minimum. So we have the x. What do you think we can do with that x value now that we have it?
Uh, Now that we have it, we can use that for the length of the pieces.
Yeah, yeah, precisely. You have your width equation in terms of x, you have your length equation in terms of x. So you just sub this fraction into both of those, and, well, that's the game. Because it says determine the, well, yeah, it says determine the length of the two pieces. The lengths of the two pieces. So I guess that means the length side of the rectangle and I guess any other sides for the
It's
square.
basically just asking for the perimeter of each.
Well, I'm not so sure what it means perimeter.
Is it asking that, no, because if I think in the start of the question it said 12 centimeter long piece of wires cut into two lengths, of which one is used to make a perimeter of a square
Ah,
rectangle. So you just ask for perimeter of both.
yeah, okay. No,
You just
that's
plugged it back
good
into the 12
context.
minus 4x and the 4x equations, I guess.
Yeah, yeah. That is good. I like that. Yeah, that context actually changes a lot because just reading this on its own made me think it was the length side of both of the shapes. But in fact, yeah, this makes a lot more sense to me. Yeah, good catch. Yeah, and so you'd sub that in, and well, that's really all that there is to it now. Um, cool. That's that.
So I guess now third question. So water is pumped into an empty tank. So it's asking for a quadratic, so v equals some amount of x. So
Hmm.
it's 1 hour. 1 hour gives 5 centimeters, and 5 hours gives 10. So we obviously know that the base of the tank is a bit smaller than the rest of the tank, I guess.
Is that good to say?
Or
So
is that no, no, no? I think it's yeah, I think that's right because it's one
yeah,
hour fills up 5 centimeters with a five, but then the next 4 hour, and then another 5 hours fills up just 10 centimeters or
yeah,
another 5 centimeters.
yeah. So it took 5 times the duration to get the same net increase in depth. Yeah, it'd be
Yeah.
wider at the top. Hmm.
So the volume of the water. So how do we, I guess, find the quadratic of this? I'm just not
Yeah,
very sure.
that is a an interesting question. It actually is on the tougher side. So let's see if we can digest some of the information that's being given to us here. So I think one thing that we could do to start with is relate or directly relate, like ignore the fact that it's quadratic for now. We could directly relate the volume to time. Yeah, volume to time to depth, because these are all related to each other. So you can say, like, for instance, after 1 hour, we got a depth of 5 centimeters. So if we're talking about like as far as depth in relation to time, we have points, right? We have points that we can plug in. So we have some d
But
comma.
that's obviously factored into the amount of volume because you've got 0.2 liters a minute and then 1 hour. But you can obviously calculate that. It's just times 60. So you get 30 liters in an hour.
Yeah, yeah, it's just a direct multiplication through zero point 0.2 liters per minute times,
It's
yeah.
60 minutes, yeah. So
And so
30
you
liters.
can, mhm,
So you could find probably the volume of it because you get 30 liters and then it's only 5 centimeters height.
yeah.
And then I
So
guess you assume it's circular, but it probably doesn't matter if it is or isn't.
yeah, so I guess first things first, we'll get that information down. So you said it was volume, yeah, volume was 30, and that occurs for because we care about depth. So volume is 30 when depth is
Five
5
centimeters.
centimeters. And then you can do a very similar thing for the second bit. Right, so after 5 hours, depth is 10 centimeters. So for 10
So
centimeters,
10 centimeters, then what? 0.2 times 300, which becomes 60 liters. Wait, I don't think that's right. I think it should be.
yeah.
Oh, I think
Hang
I
on,
did my.
the 30
Oh,
seems
yeah, the
off.
30's wrong. I think it should be, if they see if it's 12, it should be 12
Yeah,
instead.
yeah, I should have caught that. I guess we caught on there at the same time there. Yeah, so V12, 5 centimeters, V60, 10 centimeters. Um, and there's an implied thing in here, which is it starts empty. So what do you think
Oh,
that
no,
means
it,
as a
it
point?
it does say water's pumped into an empty tank, so it started out empty.
Yeah. And so what does that mean as a point that we could use?
Means that time started out at zero.
Yeah. So we could even put time in here as well if you wanted to. So time
Oh,
0,
yeah, V is zero, so V zero.
V0. And what else are we? Because we're trying to relate V to
Mm,
X.
0 centimeters.
0 centimeters. Yeah. So when you're looking at this, you've now got effectively 3 points, and we're told we have a quadratic to solve for. So every quadratic will look something like v equals ax squared plus
Plus B
bx plus
plus
c.
C.
A, B, C, three unknowns, 3 points. It'd be a three-way simultaneous. Or I guess in this case, technically a two-way, because when you have v equals 0, you can see that c is going to be 0 in this case. Because that's
Oh, is
when you...
that how the constant would be?
Yeah, because if you sub in 0 for x and 0 for v, these disappear, and you're just
And
left
so
with,
you get
yeah,
C.
c equals 0. But I wouldn't even really bother with that. This being a CAS, you would just chuck the whole thing in there. Um, You could. Yeah, it wouldn't be that
What
big.
is our x and what is our y in this terms of, because v is our volume and then x is depth, so it's a volume depth relationship.
Yep. Yeah, exactly. So your y is going to be the volume and your x is going to be the depth. Yeah, that checks out.
And so we're just calculating like, okay, so the depth is at this point going, therefore volume will be this point. Okay.
Yeah, yeah.
So,
For what value of depth do we get a specific volume?
right then. Okay, so when you just put it into the cas, it
Yeah.
would just become
So let's redefine our function with just some generic terms in it. So any times x squared plus bx plus c. It's very good to define this early on, because then when you go into do your simultaneous, menu 371, three equations, a, b, c. I think I showed you how this works before, yeah?
I
Okay, there's that. And then for our points, we had h of 0 is 0, nice and easy. Well, it would be easy if I clicked the right buttons. H of, so 5 for centimeters, and then 12 for volume. And then finally h of 10 for 60.
is, oh yeah, 60 because we're taking volume. That's right.
And then, yeah, that's going to give you the A, B, and C for your quadratic, which you would then just write out exactly
Oh,
as you see.
yeah.
Any further questions on that?
Now that makes sense.
Nice.
If this kind of question was in a if it was in a non-tech exam, what's the way to solve it? I'm just trying to remember how to solve this if it was
Mhm.
three-way simultaneous.
Well, it would be a painful thing. I can show you, roughly speaking, what you do. Um, Luckily enough, they do give you the v equals 0, x equals 0 spot, so that does make it a two-way simultaneous instead. I can give you the worst case scenario if it looks like a three-way though, if that's what you're looking for. So we could. I'm just going to make up some equations. It's probably going to break if I do it, um, but we'll see how we go. So basically, you're going to take these points and sub them into your generic quadratic, whatever that happens to be. And I'm just going to create three random equations from that. So you might have 2 equals 2a plus b minus c as equation 2, and then equation 3 might be 3 equals 4a plus b plus c. Right.
So it's just randomized, and that doesn't.
I've made randomized stuff, but you'll actually sub in these exact values. I've changed it up a bit because you didn't want to use the 0, 0 point, just to show you a worst case scenario. Okay,
Right.
so the way the three-way simultaneous works is you pick one of these variables, A, B, or C, to cancel out. Doesn't really matter which. For this, the easiest would probably be to cancel out B, since you can see it's pretty consistent across all of them. B, B, B.
Mhm.
It's very easy to use elimination method to cancel these ones out. So once you picked the variable that you want to cancel out, you then want to pick any two unique pairings of equations. So you could do like 1 minus 2 and 2 minus 3. You could do 3 minus 1 and 3 minus 2. As long as you're picking any two pairs, whatever it takes to do elimination successfully, just pick any two unique pairs. So just for argument's sake, I'm going to do 2 minus 1 to start with, and we'll see how we go from there. So 2 minus 1 means, well, again, 2 minus 1 gives you 1, 2a minus a gives you a, b cancels out as expected, and it's going to be a minus 2c. Yep. So we've done one unique pairing of 2 and 1. Now we're either going to do 3 and 2 or 3 and 1. Doesn't really matter which. I'll do 3 and 1 just because why not? 3 minus 1 gives 2. 4 minus 1 gives 3. B's cancel out. And once again, going to have, well, actually, that's just going to be C's cancel out. So to make it look a bit different, I'm going to make this a 2C. What you end up with is two unique equations that only have two variables in them. From here, you treat it like normal simultaneous, and then work your way back up to grab the remaining variable.
Right. Yeah, that makes sense. All right.
Cool.
So, in the context of this question,
Mhm.
where would you substitute the values of 60 and 10 and
Yep.
12 and 5?
Yep. So if we do it here, we start with our generic quadratic, ax squared plus bx plus c. The x
Mm-hmm.
values are these, and the v values are obviously those. So to create our equations, let's say we
Oh, you
start.
just get those you get those equations. You get 12 equals like
Mhm.
25a plus 25a plus 5b plus c, and then so on and so forth.
Yeah, exactly. You'll see they become linear pretty much every time.
All right.
So this is pretty more or less accurate to what you'd see.
Okay, that makes sense then.
Do you want to see it written out, or is that clear enough?
Uh, no, that makes sense actually. I think I can probably get it because you probably just because you just substitute the values and then solve as a for three-way simultaneous.
Yeah, well, this one would end up being 2, again, because that's 0, 0. That makes it
I
really
guess.
easy. Um, that's why I had to make one up, just so you could see what would happen, worst case scenario, if you did get to that situation.
Oh, okay then.
Okay, so getting close to end of class here. Curious to see if there's anything like super cool worth discussing, because we've gotten up to. Well, actually, no, we've just done 3A. We could probably try and do 3B by the end of it. What do you think? Speed run in a minute.
Yeah. Good to know that the maximum possible depth is 20.
Uh-huh.
Can water be pumped? Oh, so it's just asking for the maximum domain, basically. So they gave
Um,
us a x is 20. What is v? And then divide that by the time.
by time. Well, you're
Yeah, because they
told.
gave 20 centimeters, because they gave 2.2 liters per minute. So you just divide that by zero point 0.2, and then it gives you the number of minutes that you can pump for.
Yeah, it's specifically the rate that you care about rather than the actual volume. Yeah, correct. Yeah, because when you divide, yeah, you had it perfectly fine.
Yep.
Nice. Did end up doing it in less than a minute. Very good. Cool. Okay. So I guess just for your own notes, we made it up until, well, question 4 would be next for you. There's, a fair bit left as far as external responses go. Um, they'll have all sorts of different ways to rephrase things, but what you're seeing is more or less the same sort of question over and over again, realistically speaking. This one was a bit more unique, had 3 variables to keep track of, but obviously we could only
It ended up being basically just two.
yeah. Once you found the relationship between the 3 of them, you can ignore the one that's not being talked about. Like if this said connect V and T, well, we would have just ditched the x values and replaced them with the time values of 0, 1, and 5.
Yeah.
Yeah, that's about it then. So I guess keep going with those. It sounds like you got a really strong understanding of how this all works. So if you still have time after this class, then go through as many of these as you can get, and that way you can really seal in the extended response side of quadratics.
Yeah,
Sound
of
fair?
course. All right.
Cool. All right. I'll let you enjoy the rest of your week.
Yeah, you too. Thank you very much.
Take care. Bye.